as Aphrodite very well introduced us to the term heterogeneity, we are now going to see how to deal with it. So heterogeneity is always expected in a systematic review. So this is the reason that review authors should always take into account any statistical heterogeneity when interpreting their results. So if heterogeneity is identified, there is a number of options that are available. And the first thing we need to do, if heterogeneity is located, to check for data entry errors. And let's see that in a theoretical example. So in this meta-analysis, we have 9 studies included. And if we take a closer look, we can see that there are indications both from the chi-square test and from I-square index, and even from simple eyeballing, we can see that there are indications for heterogeneity. If we look closer, we will notice that there is a study, the first one, which has a very poor overlap with the rest of the studies. So what we did here is to go back to data and check for any data entry errors. And indeed, what we found is that the authors, instead of -2 points as a mean difference, the authors had used a mean difference of -2 instead of a mean difference of -0.2. So when this was corrected, then there were no indications for heterogeneity anymore in the fourth group and in the analysis. So it is very important to check for data entry errors and make sure that the extracted data are correct. Another interesting option is to explore heterogeneity using predefined subgroup and meta-regression or sensitivity analysis. So all these are methods to explore the reasons for heterogeneity in our analysis. Let's see an example of a subgroup analysis using this theoretical example. So in this meta-analysis, we have 11 different studies exploring the effects of an experimental intervention versus the control. So we can see that there is poor overlap among the studies, the confidence interval of the studies, and there are indications of heterogeneity. So now suppose that for these studies, we have also available the risk of bias assessment. So we know that the five first studies are at high risk of bias and the rest are at low risk of bias. So a reasonable analysis, a subgroup analysis, would be to perform a subgroup analysis regarding the risk of bias, according to risk of bias. And there it is. So as we can see, we have 5 studies at high risk of bias in the first subgroup and 6 studies at low risk of bias in the second subgroup. And if you notice, you will see that within each subgroup, heterogeneity is not there anymore. So we can claim that the risk of bias was the reason that a risk of bias has explained the heterogeneity we noticed when we synthesized all studies together earlier. However, it is important here to note that we should avoid multiple applications of the subgroup analysis, as it's likely to observe significant results or only by chance. And we should conduct subgroup analysis and regression or sensitivity analysis that have been defined a priori. Okay, then an interesting approach is to reconsider the effect measure that has been used. So when we deal with continuous data, the included studies may have used different scales, and such an issue is very common when we explore subjective outcomes. For example, when we explore anxiety symptoms or depression symptoms. So in such cases, if we use the mean difference between the experimental and the control group, then these mean differences may not be directly comparable across studies, as these studies may have used different scale and scoring methods, which will be different. So if we use the mean difference as the effect measure, this may result in high between study heterogeneity. And a solution to such a situation would be to change the effect size to standardized mean difference and use this instead. For dichotomous data, the choice of the effect measure may also affect heterogeneity. And let's see this issue in this example. We have two meta-analyses. Well, we have 4 studies. We have the same studies in the first and the second case, and we have performed the meta-analysis using exactly the same data. But in the first case, the effect size used is the risk ratio, and in the second case, the effect size used is the odds ratio. So what we see is that using the risk ratio and the same data in the first case resulted in very high heterogeneity, while in the second case, there is no heterogeneity at all. There are no indications for heterogeneity. So that means that we should be very careful with choosing the effect size in both continuous and dichotomous data, but here we can see this huge difference. And the choice should depend on the nature of the data, what the nature of the outcome. We may have rare events, or we may have more common events, and then there will be a difference between the risk and the odds ratio. And when choosing between the effect measure, we should keep in mind the research question, and of course, clinical aspects of the outcome examined. Finally, an option is to not synthesize the results. And let's see that in this example. So in this meta-analysis, we have the authors had included 9 studies. So they have double-checked for data entry errors. They have performed sensitivity analysis, and see that they excluded, for example, the 2 studies that seem to be outliers, study 2 and study 7. And still, well, in the first analysis, in the primary analysis, there were indications for high heterogeneity. Even when taking all this and excluding the studies, heterogeneity was still very large. So what the authors selected to do is not to proceed to synthesizing the results altogether. So now some common misconceptions that we face in systematic reviews and meta-analysis. The first one is that we usually observe that people ignore heterogeneity. And this is a major issue. We should not ignore heterogeneity, but we should find a way to assess it properly. Secondly, an I-square of 0% is often interpreted as that heterogeneity is not there. There is no heterogeneity in the analysis, which is not true, because it does not mean heterogeneity is not there. For example, especially when using I-square. For example, when we have as Aphrodite told us before, the I-square depends on many factors, including the sample size of the studies and the number of the studies included in the meta-analysis. So in a meta-analysis with very large studies or many studies, the sampling error chance will tend to 0. So in this way, so therefore, I-square will tend to be 100% simply because the single studies have greater sample sizes. So we should not over-rely on I-square. What has been commonly used also in reviews is choosing between the fixed and the random effects model based on the Q statistic of or the I-square value. So we commonly encounter situations where people say that if I-squared was over 50%, we will do a random effect meta-analysis. Well, the fixed and the random effect meta-analysis should be specified a priori in the protocol, for example, and not on the basis of heterogeneity test. And as it is very well underlined in chapter 10 of Cochrane Handbook, heterogeneity, statistical heterogeneity may be inevitable. So the test for heterogeneity is irrelevant to the choice of the analysis. Heterogeneity may be there, even if it happens or not for us to detect it using a statistical test. So the choice between these 2 models should be predefined. And of course, if you search on Twitter, there are regular reminders that remind us what I-square is and what we should not do in meta-analysis. Okay, so now the Q statistic that we saw earlier and with the chi-square test, as well as the I-square index, indicate the presence of heterogeneity or not, but they don't tell us how much the effect size varies. So this information can be provided using the prediction interval. So under a random effect meta-analysis model, the estimate of the between study variance is typically presented as part of its results. It's the chi-square. So the prediction interval, the prediction interval is an interval within which the effect size of a new study will fall if the study is similar with the studies that have already been included in the meta-analysis and can be derived easily using this equation. However, still caution is needed because to use the prediction interval under a random effects model requires a reasonable number of studies and a not significant funnel plot asymmetry, no indications for publication bias. So in the example we saw before, we have the diamond, we have the summary effect of the meta-analysis, and we also have the prediction interval, which displays also the heterogeneity, depicts heterogeneity that there is in this meta-analysis. And as we can see, it is more clear with the prediction interval that in the future study, there may not be a difference between the experimental and the control group, while in the the summary effect of the meta-analysis, this is marginally not important. So overall, heterogeneity is a common issue that we face in meta-analysis, and we need to learn how to deal with it. It is important to be careful when dealing with it to ensure that the derived results are valid and reliable. For example, these two meta-analyses have identical pooled effect estimates, but there are a lot of studies here with contradictory results, and there's only a small number of studies here where we say that heterogeneity is might not important. So which one would we trust? Large heterogeneity may challenge the trust we can place in our results, and we should be very careful with that. Overall, again, the interpretation of the I-square index should always be considered in the context of other factors, including the number and the size of included studies, the nature of the research question, and the quality of evidence. Both I-square and statistical tests should not be the basis for choosing between fixed and random effects models as we discussed earlier. And in general, random effects models gives more conservative effects. So when fixed and random effect models give similar results, then we can prefer the random effects model. But when fixed and random effect model differ, then small side effects may be present, and we should think there about the confidence we place on smaller results, on small trials. And of course, all this can be found in chapter 10 of the Cochrane handbook, where analyzing data and undertaking meta-analysis is very well described in detail. So thank you very much, and we're happy to answer any questions.
That's great. Thanks so much, Sophia. That was really interesting. Okay, so we've had some questions and discussion in the chat box, but I think that Aphrodite has possibly already answered the questions. So it might be worth just discussing them a little bit more. I think the first question was around tau squared. And so Aphrodite, you said that it provides an estimation of the heterogeneity between studies.
Yeah.
So I wonder, I'm guessing that tau squared, does that provide part of the way that we calculate the chi-squared statistic and I-squared? Is that right?
Yeah, the tau square is the estimates of the between-study heterogeneity, the between-study variance in the meta-analysis.
Okay, thank you. And I think also we had some questions around the choice of effect measure. So I think you suggested in your presentation that it might be worth looking at different effect measures when you have a lot of heterogeneity. Is that correct?
Yeah, well, we should be, well, the example I showed, there was a massive difference between choosing risk ratio and odds ratio for the same data. But Well, the choice of the effect size in a meta-analysis should be defined a priori, of course, in the protocol, and it should depend on the nature of the data. For example, the risk ratio and the odds ratio when we have rare events will probably be close, but there will be differences when the outcome becomes more common. So this will be defined by. For this, we need clinicians aspects, and we need to focus on the research question and these clinical aspects of the outcome.
Okay, that's great. Thank you. Okay, I've got some new messages. Okay, so I think from Casey, the question is, can you compare heterogeneity to transitivity in a network meta-analysis? And Sophia, that's definitely one for you.
Okay, transitivity network meta-analysis, it could be compared. Transitivity could lead to heterogeneity in large heterogeneity in results, because the distribution of effects of characteristics of studies would not be the same if transitivity does not hold.
Okay, that's great. Thank you. And a question from Lockman, who asks, do I² and tau² differ when we choose Mantel-Heinzel or inverse variance? So I guess is the choice of methods for meta-analysis, does that make a difference to the I² and the tau² statistic?
I think the way it will be calculated does not change.
Okay. So those statistics will still be the same, will they, with the different models?
Well, usually in inverse variance, we might enter some adjusted estimates, while in Mantel-Heinzel, we calculate unadjusted estimates, which might have an impact on the produced results. But usually we do, I don't think there's a specific rule here, but I think this will play a role in the between studies heterogeneity, because usually we might have some adjusted estimates in inverse variance. But if we don't, I don't think I don't know if there's substantial differences between the two methods.
Okay. Thank you. Thanks, Aphrodite. Okay, I can't see any more questions. I had a question for both of you. So you talked about using prediction intervals in meta-analyses, as well as sort of effect estimates and confidence intervals. So would you recommend that Cochrane authors use prediction intervals more generally? Because I don't tend to see those in reviews. Do you think they're a helpful statistic to include?
Well, I would say so, because the confidence intervals that are displayed assess the precision of the mean, but prediction interval of the mean, the summary effect estimates that we have from the meta-analysis, but the distribution of the true effects is assessed from the prediction interval, and it's very useful to have it there.
Brilliant. Okay. Did you have anything to add on that, Aphrodite?
No. We usually need a number of studies to have a reliable prediction interval. So I think the handbook proposes at least 10 studies in the meta-analysis. Yeah. So usually there are some practical issues which do not allow us to calculate prediction intervals. So yeah. And they're just a helpful tool for interpreting heterogeneity. It cannot give us a clear picture of its magnitude. So, yeah, it's a step. It's just a step in the process. It's not the priority calculating prediction intervals.
And of course, quite often meta-analyses don't have 10 studies. We know that from looking at lots and lots of Cochrane reviews, unfortunately.
Yeah. usually there's large heterogeneity if many studies are included in the meta-analysis. So again, there are differences in direction of effects. Confidence intervals do not overlap. So a prediction interval might be misleading in many cases. So it needs caution.
Thank you. Okay, we've got a question from Javier, which I definitely don't know the answer to. Does RevMan-Web allow the estimation of prediction intervals? I don't know, and I'm not sure whether Aphrodite or Sophia, you would know that either.
Not.
You think
now.
Not now?
Yes.
Yeah. I think that might be one of the things that's coming in RevMan-Web, as I understand it. So yes, in the future, hopefully. Brilliant, thank you. Anybody have any more questions? You can also put your hand up if you would like. Okay, I'm taking that as no more questions. So, hang on, we've got one more, last minute. How about meta-regression to explore heterogeneity? Aphrodite or Sophia, if you want to, you did mention meta-regression. Again, I don't think that's something that's that we see very often in Cochrane reviews, but
well, it's an option. We can conduct either meta-regression or subgroup analysis. It's an option. When we have, especially when we have continuous covariates, then the only choice to explore heterogeneity is to conduct a meta-regression using these covariates. Otherwise, if it's categorical, we can conduct either meta-regression or a subgroup analysis.